Hello class, today we are going to start chapter 8. Chapter 8, first section, percent, sales tax and discounts. And after this class, you need to be able to convert between percents, fractions, and decimals. Also, be able to solve problems involving sales tax, discounts, and determine the percent increase and percent decrease, and also recognize deceptive situation when percents are misused. So that's the goal of this section. So let's explain what is a percent. What is percent? And what's the difference between percent and percentage? And they mean the same thing. However, we do not put a value or number in front of percentage. But every time we talk about percent, we always need to have a number in front of percent. Yeah. Whenever we say percent, you have to be specific. How many percent? 20%, 10%, 99%, right? But percentage is the general term for all the percents. For all the percents. Yeah. Percent. P-R-C-E-N-T. You need to memorize. Per in mathematics means divided by. And cent means 100. Yeah, century. How many years in a century? 100 years, right? How many cents in a dollar? 100 cents in a dollar. So cent means 100. Percent simply means divided by 100. If let's say we have a 40%, yeah, we are talking about the percentage 40%. It simply means 40 divided by 100. And that can be expressed as 40 over 100. All right? And you can use your calculator. Divide 40 by 100. Convert that as a decimal. That is 0.4. Okay? Yeah, percent. Just remember, percent. It looks like percent always have a number in front of the percent sign. And you can translate this percent sign as divided by 100. Divided by 100. And how do we convert between percents, fractions, and decimals? Let's get that figured out through examples. First example, convert from fraction to percent. We are given fraction. We need to convert the given fraction to its equivalent percent. All right. So this is what we do. If we have a fraction, and we know what is numerator, what is the denominator, right? Yeah, numerator is the number above the bar. Denominator is number below the bar. So what we need to do is, let me make the calculator bigger. This chapter, you need a good calculator. I recommend that you use the TI-84 or 83 graphing programming calculator. That will make your job a lot easier. It's worth it. Trust me. This section is okay. This section, a simple scientific calculator will be enough. Yeah, so we are going to divide the numerator by the denominator. And we'll have a decimal, right? Yeah, we will have a decimal. And then we are going to move the decimal point 2 places to the right. Yeah, it is 0.375. We are going to move the decimal point to the right twice. And we have 37.5. 37.5. And then we are going to attach the percent sign. And that's the process, in general, the process of converting a fraction to its equivalent percent. Okay, yeah. So let me do it again. Pretty straightforward. Use the numerator to divide by the denominator. And you get the decimal. And move the decimal point to the right twice. And then attach the percent sign. Why? Let me explain. When we attach the percent sign, remember percent sign can be translated as divided by 100. Yeah, every time we attach a percent sign, we make the number 100 times smaller. But to counter that, we have to make the number 100 times bigger, right? So that's why we move the decimal point to the right twice. Yeah, when you move the decimal point in a decimal 2 places to the right, you are making the number 100 times bigger. And then you attach the percent sign. That makes the number 100 times smaller. So it's balanced out. Okay? Yeah. The second one, numerator is 1, denominator is 40. We do the same thing. Divide 1 by 40. We have decimal, and we move the decimal point to the right twice. We have 2.5, right? And then attach the percent sign. So 2.5%, 2.5%. Yeah. So how do we understand? Let's explain. How do we understand the value of this percent? Yeah. What is 2.5% really mean? Yeah. Let's say you have a pizza. You cut a pizza into 100 equal slices, very, very tiny pieces. Yeah. And 2.5 slices out of the 100 slices. That's how much 2.5% represent. Okay. Yeah, as it says here, percents are the result of expressing numbers as part of 100. Compare with 100. The word percent means per 100. Next example, we are going to see how do we convert the given decimal to percent. This is a lot easier because more straightforward. Because earlier when we convert from fraction to percent, the middle step is to go from fraction to percent. Yeah, and then from percent to from fraction to decimal, and then from decimal to percent. And this is from decimal to percent, and we know how to do that, right? From decimal to percent, we move the decimal point 2 times to the right, and then attach the percent sign. The value of the given decimal is 0.47. We move the decimal point to the right twice. We make the number 100 times bigger, and then we attach the percent sign. We balance it out. Yeah, because percent sign means divide by 100. We make the number 100 times smaller back. Yeah, the value-wise the same. They look different, form-wise different. This is a decimal form. This is a percent form, but value-wise they are the same. They are equal. In mathematics, we need to be very careful using the equal sign. Okay, this one, the decimal is 2.87. Yeah, how do we convert that to percent? Same thing. Move the decimal point to the right twice. Then we have 287, and then attach the sign. Okay. When the number in front of a percent is more than 100, that means the value of the number represented by the percent is more than 100. Compared with 100 is more than that. It's like 2.87 is like you have one whole pizza with another whole pizza, but you don't have 3 whole pizzas. The third pizza, you only have 87 out of 100 slices. Okay, part C. Same thing. We move the decimal point to the right twice. We have 0.3, and then twice 0.3, and then attach the percent sign. Okay, this number is very tiny. Next example is to convert the given percent back to decimal. Go backwards. Yeah. To write a percent as a decimal, we cannot keep the percent sign. We have to drop it, right? Yeah. So, but when we drop the percent sign, we actually make the number 100 times bigger. Remember, when we have the percent sign, that is 100 times smaller, right? But now we are dropping it, so the number is 100 times bigger. To counter that, to reverse that, we have to move the decimal point to the left 2 places to balance it out. So this is what we do. 19%, 19. we firstly move the decimal point in 19 to the left twice, and we got a 0.19. And then drop the percent sign. Or you drop the percent sign first, and then move the decimal point to the left twice. Same thing. Yeah, I normally drop the percent sign first, and then move the decimal point to the left twice. Same thing here. Drop the percent sign, and then move the decimal point to the left twice. And you might wonder, where's the decimal point? I don't have any decimal point. 180 is a whole number, yes, but we could write a whole number as a decimal as 180.0, right? And remember, when you write a check to someone, let's say $100, $180, you do not just write 180. You write 180.00, right? Yeah. So it is a whole number, but you can write a whole number as a decimal. Yeah, knowing the decimal point is right by the foot of the last digit. With that said, we can move the decimal point to the left twice. We got 1.8. 1.8. Part C. Yeah, this one might be a little bit challenging because in front of the percent sign, we do not have a whole number. We do not have a decimal. Yeah, where's the decimal point in half? Yeah, we have a fraction. When that happens, this is what we do. We convert the fraction to its equivalent decimal first. Okay, yeah. So 1/2, we all know 1/2 is 0.5. And with the percent sign, okay, yeah. 1/2 is 0.5 with the percent sign, so 0.5%. You cut this pizza into 100 slices, equal slices, and half a slice is how much that value, that percent represents. Okay, now we're gonna convert that to decimal. It's different, okay? It's different. Yeah. Earlier we are converting this fraction in front of percent sign to its decimal equivalent. Now we are converting this percent to its decimal equivalent. So we drop the percent sign and then move the decimal point to the left twice, 0.005. Okay, yeah, this is how do we do it. We have 0.5. We move the decimal point to the left twice, once, twice, 0.005. Okay, 0.005. Of course, you can always use the calculator to assist you. Next, we have a very, very important formula. And you can find that formula in my table note as well. It's right here. Okay. How do we translate the sentence that A is X% of B? It is A equals X% times B. Let's go back to the guided notes. A equals percent P% times B. Yeah, OF here implies multiplication. Yeah, in algebra, those two things you need to memorize or include in your notes. PER means divided by. OF means multiply by. PER means divided by. OF means multiply. In my table note, I also have a different way to apply that formula. Yeah, but we don't have to. Yeah, at this point we don't have to. How do we apply this formula? We can apply the formula to solve problems involving sales tax. Yeah, sales tax. We are pretty familiar with the sales tax, right? In this country, whatever you buy, you have to pay a sales tax. Yeah, the price of the product, you pay the store, the business owner, and the sales tax incurred from your purchase goes to the government. Yeah, either local government or federal government. So let's see. The formula for sales tax amount. Yeah, is sales tax rate multiplied by the item's cost. All right? Yeah, because amount-wise, the sales tax is a percent of the item's cost. Yeah, so that's how do we apply, how does this formula apply in this situation? Yeah, sales tax amount-wise is a percent of the item's cost. Yeah, how many percent depends on the tax rate, right? Yeah, in Tulsa, what is the tax rate? Like a, yeah, let me see, what is the sales tax in Tulsa? I remember when I was in Florida, it is 6%. Sales tax in Tulsa, Oklahoma. Yeah, 8.52%, not too bad. Yeah. Where the town I live is 9-ish. It's higher than that. Even just the two adjacent town, the sales tax is different. Depends on the local government. Okay, so because sales tax amount-wise is a percent of the item's cost, so sales tax amount equals the tax rate multiplied by item's cost. Yeah, you can also understand that by using this chart. I use this chart; it's very efficient. And the top part is a part, and then bottom left is a percent, bottom right is a whole. Yeah, every time I only recognize what is part, what is whole, what is percent, and this chart would tell us how do we operate them. Part equals percent times whole. Whole equals part divided by percent. Percent equals part divided by whole. I believe we would have a chance to apply this chart in later sections. In the case of sales tax amount, it is a part, amount-wise is a part of the item's cost, right? So part equals percent times whole. Okay, let's apply that formula. Yeah, you need to make effort and spend time to memorize, understand and memorize those formulas, because our tests are gonna be closed book, closed note. Let's apply the formula. Suppose that the local sales tax rate is 7.5% and you purchase a mountain bike for $894. How much tax is paid? As I explained earlier, amount-wise, sales tax amount is a percent, yeah, of the item's cost, item's price. Yeah, the percent is the tax rate. In this case, is 7.5%. Yeah, multiplied by the item's cost. The item's cost is 894. Okay. And then you can use your calculator to process it. Let me show you how do I use a calculator to process the value. Let's go back 0. Yeah, 7.5%. You can totally use your calculator to get that done. 7.5 divided by 100, because percent means divided by 100, right? Yeah. So the value is the same with if you drop the percent sign and move the decimal point to the left twice. Yeah. And then multiply that by 894. Also, in a scientific calculator, you might have the percent function. That makes it even a lot easier. So 7.5%. Did I enter anything wrong? Okay, let's do that again. 7.5%. Oh, it's gonna be 7.5%. And it didn't work. Try one more time. 7.5%. Okay, never mind. Just we already show you how do we convert that to percent, right? Convert from percent to decimal. So 7.5 divided by 100 and multiply that by 894. 894. We have 67.05. 67.05. You can put a dollar sign in front of it. $67.05. That's how much tax you need to pay to the government. Not just the cost of the mountain bike, not just paying the store, you have to pay the government. Part B, what's the mountain bike's total cost? Yeah, the cost has two parts. Yeah, part of it go to the store, part of it go to the government, right? So the total cost equals the sales, the items cost plus the sales tax. So that is mountain bike is $894 plus 67.05. Okay, yeah. So add, we have this number still in the calculator. Yeah, on top of that, add $894, 961.05. Total cost is that. So when you budget, when you when you plan to purchase a big item, sometimes you have to plan your finance to purchase an expensive item, right? Then you need to include in the sales tax, because that's not a small money. It's not like a little money. It's quite a big chunk of the cost. All right, so one more time to go over the formula. Sales tax amount equals tax rate multiplied by the item's cost. Because amount-wise, the sales tax is a percent of the item's cost, and the total cost of the item is the sum of the price of the item and the sales tax you pay the government. Next, let's see how do we apply the percent formula to solve problems involving discount. That's something pleasant, right? Very often when a business promotes their products, they will give you a discount. How many percent off, right? Okay, here, the discount amount is a percent of the original price. Yeah, you supposed without the discount, without the promotion, you probably have to pay the whole. And now they have like a 25% off. So you cut this chunk off. You don't pay this part. You only pay the rest, the 75%. Yeah. So discount amount is a percent of the original price. That's how do we have this formula about the discount. Discount amount equals discount rate. That depends on the business, right? 20% off or 70% off or 30% off. That determines how much money you save. The discount rate multiplied by original price. Let's look at the example. A gaming laptop with an original price of $1,460 is on sale at 15% off. Yeah, A, what is the discount amount? Okay, let's do the formula. You have to understand the formula when you apply it, okay? Discount amount equals the discount rate multiplied by, use this notation, original price. So in this case, it is discount rate. Discount rate is 15% multiplied by original price. Original price is 1460. Oh, 60. Okay, and then you are gonna just calculate using the calculator. Manually calculate expressions is not the focus of this course. Is the foundation, is the purpose of your algebra foundation class. So I actually recommend you use a calculator, because I do not want to. I want you to mess up your score just because you calculated wrong or rounded it incorrectly. 15% is a 0.15, right? Just move the decimal point to the left twice, or you can just do 15 divided by 100. That is the decimal equivalent of percent, 15%. Multiply that by the original price, 1460. We have $219. $219. So how do we explain or interpret that result? The original price of the laptop was $1,460. Now it's on sale, 15% off. So you are going to pay $219 less. So the actual price, or the sales price, would it be the original price minus the discount amount? In this case, you subtract 219 from the original price, 1460. So you use 1460 to minus 219. 1460. 1460 minus 219. $1,241. 1241. 1241. 1241. Yeah, $1,241. That is a couple weeks grocery, right? Yeah. So that's why people are crazy when on the Black Friday, when on holiday the business have a promotion. It always works. It always works because it saves you money. All right. The two formulas involving discount. The first one, discount amount equals discount rate multiplied by original price. The second one, the sales price, the actual price you pay without considering the tax, of course, is your original price minus discount amount. Okay, next topic in this section is to calculate percent increase and percent decrease. Let me give you my formulas for percent increase and percent decrease. I don't really like the two formulas on the note, so I'm going to give you my own formulas, right? I'm going to write it here. Actually, I think I have it in my table note. Let me show you. Percent increase, right here. Those two formulas. Percent increase. Oh, actually, that's not what I want either. So this is what I actually like. I'll write it right here. Percent increase equals the new value minus original value all over original value. Percent decrease that means original value is higher, right? Yeah, original value is higher. So you use original to minus the new. The new is smaller, and over original. Same with the formulas on the guided notes, but you will see the convenience of using these two formulas. Okay, So new value, when the amount goes up, that means the original value is smaller, the new value is bigger. And if you use the new value to minus original value, then that's the amount of increase, right? Is right here in the numerator. And then in the case of percent decrease, when the value declines, then the new value is smaller, original value is bigger. So the original value minus the new value is the amount of decrease. Use that to divide by original. The important thing is the denominator has to be original. denominator has to be original, all right? Okay, let's apply it. Yeah, I hope you do the same thing with me when you when you try to find a percent increase and a percent decrease. Part A. If 6 is increased to 10, find the percent increase. Okay, this is what we do. Firstly, we write down original. Original value is 6, right? And the new value, yes, the value go from 6 to 10. So new value is 10. Yeah, write that down on your scratch paper, okay? Write that down on your scratch paper. And then you are going to copy the percent increase formula equals let's try this, divided by original. Okay, yeah, it works. And numerator is the new minus original. Yeah, I recommend that you do what I do here. Okay, equals now let's plug in the values. New value is 10. You might wonder, why do you need make it so complicated that I have to copy the formula every single time? Trust me, many students have problem finding percent increase, percent decrease. Even it is actually a simple problem. Denominator original. Very important. Denominator is always original. Denominator always original. 6. Okay. All right. Yeah. Please do the same thing as I just did. You know the correct order of operations, right? Yeah. So you process the numerator first. Numerator is 4. 10 minus 6 is 4. 4 divided by 6. You have a decimal. And then you're going to convert a decimal to percent. Well, in this case, we would have to round it. When you do the homework in MATLAB Math, you need to be very careful the rounding. You have to do what the problem asks you to do. Yeah, how many decimal places to keep, and etc. I need to use the approximately symbol. Sorry, it takes so long. Oh, here we go. Right here. Perfect. Right? Yeah, approximately equal to, let's keep 2 decimal places, 66.67%. 66.67%. How do you round it depends on the question when you work on the assignment in MATLAB Math. All right, that's the percent increase. Part B. Part B. If 10 is decreased to 6, find a percent decrease. And same thing, original 10. The part B has nothing to do with part A, okay? Those are two separate problems. And new value is 6. And you are going to copy the formula. Yeah, what's the formula? Percent decrease equals original minus new divided by original. Yeah, so this is a wrong structure. Go here. Okay, this is correct. And that equal to numerator is original is 10, new is 6. So 10 minus 6, right? It's still 4. It is still 4. But what's the denominator? It's going to be 10 or 6. Has to be original. Has to be 10, okay? Yeah, this is the main difference. 4 over 10 is 40%. 4 out of 10 is 40 out of 100 is 40%. So the percent decrease is 40%. Percent decrease. Just something to point out. In case in other books you see percent change, what's the difference? You don't have to worry about that in this course because we use percent increase, percent decrease. Both of them is going to be positive. Things about percent change is you have to have the sign in front of it. If your percent change is positive, that means is increase, your percent increase. If your percent change is negative, that means your percent change is a percent decrease. But again, we don't have to worry about that. Both values of percent increase and percent decrease, they are positive. Again, very important, the denominator must be original. That's the reason I recommend you write down original and new the very beginning. Next example, a pair of jeans regularly sells for $135 and is on sale for $60.75. Find the percent increase. Yeah, whenever you see you are going to find the percent increase or percent decrease, this is what you do. Original, new. The original price is $135. New price is 60.75. Okay, and we are looking for percent decrease. Percent decrease. Let's get a formula. Let me copy from the previous question. Percent decrease. This one? Okay, percent decrease. Okay, percent decrease is original 135 minus new 60.75 all over original. Yeah, you have your original written down here. So all you need to do is to plug in 135 and you will not mess it up because it's right there. You write it on your scratch paper. That's original. Okay, let's operate that. Calculator. 135 minus 60.75 equals, that's the numerator. Divide that numerator by 135. 0.55. Yeah, that is the 55%. At the end of this chapter, or along the course of learning this chapter, you need to be able to convert the result to percent if it's needed very, very quickly. Yeah, convert from fraction, decimal, yeah, and percent very, very quickly. So the percent decrease of the price of the item is 55%. Okay. Yeah, what is that? That actually is the discount rate, right? In this case, yeah, discount rate. The last topic of this section is about deceptive situations in which percent are used incorrectly or abused. Yeah. So now we will look at one of the ways that percent can be used incorrectly. Confusion often arises when percent increase or decrease refers to a change in quantity that is itself a percent. Okay, so that is one situation in which confusion may arise. Let's look at a specific problem. On my table note, I also have an example about deceptive situation regarding percent. It's right here. Your boss told you if you accept 10% decrease this month and next month they will raise your salary to 10% and you will have your original salary. Do you buy what he said? Yeah. So you figured out. I have the details in my table note. And the video, we focus on answering the questions on the guidance notes. A politician states, if you elect me to office, I promise to cut your taxes for each of my first 3 years in office by 10% each year for a total reduction of 30%. Yeah, I guess this politician not good at math class. Evaluate the accuracy of the politician's statement. Let's analyze the situation, okay? I'm going to make a table. 1 year, 2 year, 3rd year should be enough. So end of year 1, end of year 2, end of, oh, I need one more row, end of year 3. And this column we're going to do tax, and this is a actually tax end of, I'm going to do one more. So this is year 0, the very beginning. This is year 1. This is year 2. You can have your own way to organize the given data. You don't have to do what I do, but this is one efficient way to analyze the situation. And this is a tax cut. Tax cut. So the very beginning, let's say the tax is T. We don't really have an amount, so let's just use a letter representing the variable here. And the first year tax cut is 10%, right? Yeah, so 10% of T. So 10% times T, that is 0.1 times T. And by the end of year 1, the tax, the new tax, is changing. Okay, tax here is a variable. It's gonna be T minus 0.1 T, and that is 0.9 T. Do you follow? Original tax is T. So during the first year, tax is cut by 10%. So by the end of year 1, the new tax is 0.9 T. Okay? And during the second year, the tax cut is another 10%. So 10% of the tax. I think maybe I should switch the 2 columns. insert column to the right. Yeah, the tax cut no does not apply originally, and tax by the end of the year, the very beginning is T, and during the first year is 0.1 T, and by the end of the year 1, the tax is 0.9 T. Yeah, and during the second year, the tax cut is 10%, not 10% of T anymore. Okay, 10% of the tax of last year, 0.9 T, and that is 0.1 times 0.9 T. That gives us 0.09 T, 0.09 T, 0.09 T, and we are going to subtract that from the last year tax, 0.9 T minus 0.9 T is the tax beginning of year 2, right? By the end of year 2, you're gonna subtract 0.09 T, and that gives us 0.81. You take algebra class before this class, so you should understand those expression. 0.9, we can combine like terms or factor out T. 0.9 minus 0.09, 0.81 T. Okay, so that's the tax beginning of year 3, right? During the year 3, another 10%, but that 10% is applied on 0.81 T, not the original T, and that is 0.1 times 0.81 T, and that gives us 0.081 T. At the end of year 3, we subtract that from tax of the last year, 0.81 T minus 0.081 T equals, and let's use a calculator for that, 0.81 minus 0.081, and 0.729, 0.729 T. I have an extra column here, right? Okay. And this column, I'm going to delete it. So now we can summarize. After 3 years, the reduction after 3 years is so this actually is 72.9%, 72.9% of T. And subtract 72.9 from 100. Oops. 100 minus 72.9, 27.1, 27.1, 27.1%. Yeah, the reduction after 3 years is 27.1%, not 30%. And the mathematics doesn't work that way. Of course, 30% is higher, looks better, right? And the actual reduction is only 27.1%, but not very a lot less. Let me double check. So original test is T. After 1 year, 0.9 T. And after second year, 0.81 T. Yeah. So 0.81 times 0.9 again is 729 and 27.1%. Yeah, that's correct. All right. Yeah, that's how do we evaluate the accuracy of the politician's statement. His claim is close but overestimated the actual reduction. Next example, that's the last one, right? The price of a color printer. The price of a color printer is reduced by 30% of its original price. When it still does not sell, its price is reduced by 20% of the reduced price. The salesperson informs you that there has been a total reduction of 50%. Yeah, he did the same thing with the politician in previous example. Simply add 30% with 20%. It's not that simple. Is the salesperson using percentages properly? If not, what is the actual percent reduction from the original price? We are going to do the analysis the same way with earlier, okay? Reduce twice. Let's try make a table. You'll see I like to make tables to organize the data. After first time, after second time, after first time reduction, price reduction. This is after second time reduction. And this is the price reduction, price change or reduction. This is the price. This column is extra. Original price, let's say P, we don't really know. Sometimes you can use 100, like a convenient number, but more formally, let's use P to represent the price, original price. And we do not have reduction before the first time. And after the first reduction, the first reduction is 30% off, right? So the first time reduction, I'll just write first time. It's the second time. Price reduction is 30% off. 30% of P. And that is 0.3. 0.3 P. So new price would be 0.7 P. You see the difference, right? Use the original price to minus 0.3 P, and that gives you 0.7 P. And then the second time reduction, 20%. But that 20% discount does not apply to original P. Instead, it is applied on 0.7 P. And that gives us 0.2 times 0.7. 0.14p. And we use the previous price, not original p, is 0.7p minus 0.14p. That gives us 0.36p. Let me double check. So 30% the first time, so 70%. And then 20% again, so 0.856p. Yeah, seems right. And so after twice reduction, the actual reduction from the original is actually p minus 0.36p. That is 0.44p, and that is 44% p. All right. Yeah, 44%. The actual reduction is actually only 44%. Our original, not a 50%. Yeah, the salesperson also overestimated his claim. All right, so that's everything from this section. You can now work on the assignments in MATLAB Math. If you have any questions, feel free to email me. I'll see you in the next video. Bye.